All right, are we ready? Okay. First of all, it's fantastic to be here in my home country, Australia. My name is Peter Scarfe, for those of you who I haven't spoken to and met in person. I may not sound Australian, but I promise I am. I've been living in Switzerland for the last 15 years, so my accent is probably a little bit diluted. Every time I fly back, people ask me where I'm from. I was born in Melbourne and grew up in Perth, and I've been living in Switzerland for the last 15 years. So this presentation is about a project which is my passion project. It's what I do in my hobby time. Yes, some people do develop LabVIEW in their hobby time. And I've been doing this for the last 8 years, and it's called Workers for LabVIEW. So let's start by introducing myself to explain why I'm standing here in front of you today. So I started off studying mechatronic engineering at Curtin University of Technology in Perth. I did a bachelor's in mechatronic engineering, followed by a PhD in computer science and machine learning, where I was developing feed-forward neural network controllers in C and C++ on real-time Linux systems. But as a mechatronic engineer, you learn about system integration, system development, in a very modular kind of way. So this is the way my brain, was always kind of working, modular system integration development. In 2009, I moved to lovely, mountainous, snowy Switzerland. And it was there when I was first introduced to LabVIEW. For the first 2 years, my projects were C, C++, and LabVIEW. As a typical engineer, we don't like reading manuals, we like diving in headfirst. So my first few LabVIEW projects were cute, super large VIs full of spaghetti code. However, in 2011, I got a job as a SCADA development, supervisory control and data acquisition. I was employed to create SCADA applications for several of the experimental setups at the university. And I wanted to use LabVIEW to do this because LabVIEW is produced by NI, and NI also produced the hardware, so the interfacing was very easy. But I didn't want to create spaghetti applications, so I took the LabVIEW Core 1, Core 2, and Core 3 course. In the Core 3 course, I was introduced to the National Instruments LabVIEW queued message handler template, which I thought was fantastic. I could use this to create every asynchronous process in my for my applications. However, it doesn't scale well. You have to do it yourself. So I was looking around for a framework at that time in 2011, 2012. Couldn't find one. Asked the NI representatives back when there was a regional office in Switzerland if I was missing something. Like I came out of the Core 3 course and I wanted a framework that would allow me to take what I learned, but apply it in a flexible, scalable, and modular way. But there wasn't. So I spent, my head exploded when I realized that, first of all, because projects that I thought were going to take weeks ended up taking months, and they still weren't implemented in an optimal way. So I had no choice. I did the best I could. In 2017, the project that I was working on at the university, the funding got cut. Switzerland and the European Union had an argument, so the EU just kind of shut funding off, as they do. So I had to find another job. I took a job as a LabVIEW consultant for a small LabVIEW consultancy company. I was sent out to LabVIEW, to different companies to solve their LabVIEW problems. But it was part-time because I wanted to spend the other 2.5 days a week creating a framework that would allow me to develop flexible, scalable, and modular applications in the future. I didn't want to continue using LabVIEW. I loved using it without a framework that would allow me to be a lot more efficient in my application development. And so I started to create what I'm introducing to you all today, called Workers for LabVIEW. So by 2021, we're already at version 3. Version 3 was being used by a few small companies in Switzerland. A few of the people that I was working with, they were very helpful, providing me with feedback, how to implement things better. They also were able to test all my alpha and beta versions of every release. And Today we are at version 5. Version 5 was released last year, and it's what I'm presenting today to everyone. And this year, I guess because of my efforts in the LabVIEW community producing the framework, it's completely free, by the way, I became a LabVIEW champion. Thank you. Yeah, wiping off the tears. Okay, so welcome to Workers for LabVIEW. What is Workers for LabVIEW? So Workers for LabVIEW is an asynchronous modular framework for LabVIEW. And you can use it to build scalable, asynchronous, modular applications. It's in the same realm as DQMH or the Actor framework. So now we have a third flavor. So now we have chocolate, vanilla, and strawberry, and Workers is one of them. So Workers for LabVIEW allows you to develop applications in the style of the NI Qt message handler template using object-oriented modules. The framework allows you to build scalable, structured hierarchies of modules that form an application. And you communicate between the workers or the modules. So a worker in the framework is a modular Qt message handler. DQMH, modules, Actor framework, actors, Workers for LabVIEW, workers. And we communicate between our workers using public and also local APIs. The framework uses object-oriented modules, so it supports the creation of API abstractions and hardware abstraction layers. And this is all assisted by the use of a comprehensive suite of scripted development tools. There is a centralized local network debugger to help add transparency at runtime to your workers running anywhere on your local network. And the quickest way to learn the framework is through the Workers 5 training course. It's a completely free training course. I'll talk about this later on. It was released before Christmas last year, so it's been around for about 5 months now. And then I'll also talk a little bit about the LabVIEW, the Workers for LabVIEW community website, which is now available as well. So let's begin. So you develop in Workers using National Instruments Qt message handler style Qt message handlers, basically. Why? Because these are familiar, accessible to developers even at the NI Core 3 level, and they've been used by NI developers, by LabVIEW developers for decades now, so they're very proven as well. So this is what the Qt message handler of a worker looks like. It exists on the block diagram of every worker's main VI. When you create a new worker, this is what you will get. Every worker's Qt message handler needs to have a message handling loop because it's a message-based framework. Messages come in to the Qt message handler via the DQ message VI here. Event handling loops are optional. You only need them if you want your main VI to handle front panel events or user events. But this is the style. This should be immediately identifiable to all of you in here. I'm sure you're all at the NI Core 3 level and above. So this is the development style. Yes, we're using a message handling loop with a case structure. And we create applications using object-oriented modules. Now, OOP is one of those things in software development where it takes a while to get your head around. If you start with procedural programming, as I did, and then you learn OOP, you need to develop new neural connections in your brain to understand how to develop applications using objects. OOP should be thought of as a tool, okay, and only used when you see a nail. If there's a screw, use a different tool. But I created this post on LinkedIn last week, which points to an article that I wrote last month entitled "To Object or Not to Object, That is the Question." And what I mean by that is that too little OOP or too much OOP can both increase the complexity of your architectures, but in different ways. So the reason I started to use OOP was because without OOP, my applications were too rigid, too repetitive, and difficult to scale. So then what I did is I thought, okay, now I understand OOP, everything became an object. That increased complexity as well, but in a different way. My code was too bloated, my code was hard to read, and my code was frustrating to debug. So if you're careful about what you turn into an object, your architectural complexity will decrease. And then there's a sweet spot in the middle where you end up with cleaner code, faster development, easier debugging, and most importantly, happier developers. And this is what I wanted to try and achieve with the Workers framework. Okay, so what I tell developers that come to me and say, hey, can I use the framework? I don't have any object-oriented programming experience. I say, absolutely. It's designed for developers that don't have any OOP experience. You only need to think of LabVIEW classes as a library with superpowers. The only use of classes in the framework is used to encapsulate the modules. So instead of using a library with a public API and a main VI, we can instead use a class. There's no downside to that. It also acts as a container for a module's public API, support VIs, type defs, queued message handler. But we can add it to a class, and the class comes with extra features as well. What are the superpowers? Well, if we know, those of you who have used classes know that, first of all, there's inheritance. Inheritance means that we can move common code from every module into a common base class. And this reduces the boilerplate code in every module. The boilerplate code is the repetitive code that exists in every single module that is there just that you shouldn't touch, but it is required for the use of the framework. So we can remove this, put it into a common base class, which significantly reduces the number of VIs in a project, especially for very large projects. Every time you create a new worker, it only contains one VI, and that is the main VI. All the support VIs exist in a common base class, which the users shouldn't touch. The second superpower is abstraction. It allows us to separate a worker's public API from its implementation. Why is this useful? It allows us to create hardware abstraction layers. Polymorphism is the next superpower. It allows us to override base methods with module-specific logic. And this allows us to change the implementation with runtime extensions of certain VIs. And then we have encapsulation. It means kind of two things. First, it's like encapsulating in a container a worker's VIs, type defs, public API, but it also enforces that the object data owned by the class is only accessible by the VIs that are owned by the class as well. So it protects the object's data from being accessed and modified externally to the class. So the framework allows you to create structured modular hierarchies of workers. This allows us to create clean, scalable architectures from the get-go, and it also provides us with clear initialization and shutdown sequences. So why do we want to do this? Because back when I started developing with LabVIEW, and I had my frameworks that didn't plug together. See, Workers allows you to plug modules together to form trees. So before I had this framework, I would think, okay, I have my architecture. I'm going to create one module, two modules, three modules, four modules. And before I know it, I've created this. I call this spaghetti architecture. It's where I start to scale and I'm lazy and I start coupling everything together. And what happens here is after a while you build up technical debt, okay, and this becomes harder and harder to scale and more fragile as you continue to grow it. Okay, we don't want that. So with workers, say you have a LabVIEW project. Here we have 15 workers. Every single class is a worker, and we want to structure them together to form an application. With workers, we would start by adding the head worker, like as a root actor, to our application. And then we would use the scripting tools to plug additional workers through their public APIs into their callers to build up slowly a structured hierarchy of workers which form your application. And messaging occurs over the tree, not between any worker to any other worker. And every worker is only coupled directly to its caller. So you only have one coupling point. This diagram here, this tree, is actually created for you by one of the scripting tools called the Worker Call Chain Viewer tool. This tool will basically iterate through all the workers in your project, find out the worker call chain relationship between them, and create this tree diagram. So you don't have to do this yourself. Because here we only see a list. You don't have any information about how workers are actually connected to each other. Workers communicate with each other via decoupled public and local APIs. Workers only talk to their caller and no one else. This makes every worker decoupled from its caller and from every other worker, easy to test, and it makes the messaging between your workers traceable. So for example, if we have a worker called motor drive, we can send, number one, an asynchronous message to the worker from an external source, such as from a worker's caller or from test stand or any other VI. This is an asynchronous message. If we want to send a synchronous message, means we don't mind waiting for the VI that sends the message to the worker to block execution, then we can use a request with reply to receive a reply message back from the worker that the message was sent to. Workers can also send an asynchronous message to their callers, which are called a public response, but the caller must register the public response in order to receive it from the worker. And then we also have local requests, which are messages that can only be sent from the worker to itself, from its event handling loop to its message handling loop, or between message handling loop cases of itself. So these are the four API calls that we can create for a worker, and these are all owned by the worker itself, which means that the worker is completely decoupled from its caller. So this is a standalone package that I can create. I can post it on GitHub. Someone else can pull it in to their projects and plug it directly into their applications. The framework uses object-oriented modules. So it supports the creation of API abstractions and hardware abstraction layers. This adds an extra layer of flexibility to our applications because we can swap workers in and out at runtime without rewiring anything. So let's say we have 3 different workers, okay? Worker 1 communicates to a Bosch motor. Worker 2, worker 2 communicates with an ABB motor. And motor 3 doesn't connect to a motor, it just simulates a motor. Now we can create the same public API for each of these 3 workers. They're basically going to have the same call: start motor, stop motor, set direction, retrieve error, reset motor, etc. We can create 3 separate set of APIs for these, or we can inherit each of these 3 workers from a common base class, let's call it motor drive, and we create the public API, so all the request VIs, in the motor drive base class. And then in each worker, we only implement the unique logic that communicates directly to our hardware devices. So this allows us to create a shared set of public API VIs for multiple workers. What does this look like in the framework? Well, let's say we have our base class called motor drive. in it we can implement the public API. You can see we have all our requests, emergency stop, reset motor, set direction, etc. And then in every worker that inherits from the base class, in their message handling loops, we will implement the unique logic for each worker. So again, one set of API VIs for multiple implementations. And how would we use the API? Well, let's say we have our API VIs here, reset motor, set speed, etc. These could be called from test stand or from any other LabVIEW VI. At runtime, we can actually select which worker we want to run on the API abstraction. So we can plug our API abstraction into an application without changing any wiring. And at runtime, we can select which worker to run on the hardware abstraction layer. What this looks like in terms of our applications tree, every worker is plugged into its caller via the worker's public API. So here you can see our little legend in the top. We have 1, 2, 3, 4, 5, 6, 7 workers in our application. 2 of them are dynamically loaded at runtime. And we have a public API in a base class. What this allows us to do is to completely separate the business logic of our application from the hardware devices. And at runtime, we can select which implementation we want to plug in to our application. So we can test our motor drives separately from the rest of the application and the application separately using a simulation motor, a simulation worker. It allows us to basically isolate the testing from both the application and from the hardware devices. We create workers, create application trees, create public APIs, and hardware abstraction layers using the scripting tools to help us develop much faster. They do the heavy lifting for you, the tools. This is what the Workers Tools menu looks like. So if you install Workers into LabVIEW, you can access the Tools menu from the LabVIEW project, Tools, the Workers Tools menu. It's the one place that you go to access basically all of the tools. I'm going to quickly go through the main tools. The first one is the Create Add Worker tool. You use it to create new workers and plug them together to form your scalable trees. The second tool is the Debug Server tool. I'll talk about this in the next slide. Then we have the Call Chain Viewer tool. This tool creates the trees that you saw on the previous slide. The RT Worker Convert tool. This tool you'll only use if you're developing workers applications on NI-RT systems such as a Compact Rio. I'm giving a presentation at the GLA Summit at the end of next month, I think, called Using Workers for LabVIEW on NI Real-Time Systems. So if you're interested in how this tool works and how to develop applications on NI Real-Time Systems using the framework, then please attend the presentation. The Worker User Library contains 3 workers with pre-developed functionality with public APIs that you can plug directly into your applications. The first worker is a message pump. So if any of your workers need a message pump, you can simply add the message pump worker to your projects and plug it in directly to your applications. There's also TCP server and client network endpoints that come with the Worker User Library. So if you're developing a workers application on a Compact Rio and on a host PC, you want them to communicate with each other, then you have the TCP server and client functionality in this tool that you can simply plug into your applications. Then we have the Public API Builder tool. It allows you to create your public API requests, responses, etc., and hardware abstraction layers. There are more tools in the drop-down menu here that are not important enough to receive a nice icon. And then we have example projects available here. I think there's 12 in total. There's 5 that come with the framework and an extra 7 on GitHub. Okay, so the framework comes with its own dedicated debugger. And the debugger, for me, is the most important tool in the toolkit. And it was developed alongside the framework from version 1. I mean, as an engineer, there is nothing worse than having a black box system that you cannot debug. It makes the efficiency of the project development so much slower and so much harder if you don't have a quick way to make your system transparent when it's running. So the Workers Debug Server is a centralized debugger for all your workers running anywhere on your local network, independently of the platform that they're running in. Wait a minute. So we have the Workers App Server. So the Workers Debug Server application is a Windows application running on your host PC. And it doesn't matter if your workers' applications are running in the LabVIEW development environment, in an EXE, in a PPL, or on a compact RIO over the network, you can access and see what's happening in your applications at runtime via the debug server application. Because there's nothing worse than creating an application in LabVIEW, deploying it on a real-time system, and you're completely in the dark. And it doesn't work because some file path or something is slightly different when you're running it on the RT system. I've had these situations happen too many times to me. They annoy me, so this is my solution to that problem. There's two main parts to the debug server application. When you load it, it'll come up with the application manager. The application manager shows you a list of all your workers' applications that are running anywhere on your local network. You can see the IP address here of the hardware device that your applications are running on. You can also see the tree architecture of all the workers in your application. You can see the status of your workers. You can also add custom statuses if you like as well. You can pop up the running front panel of every worker's main VI that's running. So they're clones. Every worker is a clone, is clonable. It's an object. And you can also shut down your workers' applications remotely via the application manager as well. The second part of the debug server is the worker message logs. So these message logs show you the flow of messages around your application at runtime. It shows you where a message was enqueued, in which case of which worker, to which case of which worker the message was received. So start point to end point of your messages. It also shows you when and where any errors have occurred in your applications. And it also allows you to add filtering on your message logs, and it also allows you to log in real time all this information to file. So then you have a log of what was happening in your application at runtime, and you can analyze the data later on. Clients also like this tool because it allows them to kind of keep a log of what goes on in their application while they're using it. Again, this works in executables, PPLs, and on compact RIOs and real-time systems. So that's the bulk of the framework. Now I'm going to quickly talk about the Workers 5 training course, which was released, as I said, December last year. It's a free training course for all developers, and it's developed in the style of the National Instruments training courses, if they're still the way I remember them. So there's two parts to the training course. They're downloadable PDFs from the Workers website. The first book is the course manual. The second one is the exercise book. So these courses, this course was designed as a 2-day course that I give, but you can also download these two books yourself and work through it step by step. So the first part of the course, there's two parts, goes through all the foundations of the framework, goes through the core pillars of the framework, and introduces you to the different parts of a worker. It shows you how to build structured applications with multiple workers, how to create local and public APIs for your workers. It goes through all the scripting tools, teaches you how to debug your applications with the debug server application, and part 2 then introduces you to the OOP features of the framework, where it shows you how to leverage inheritance, abstraction, etc. So part 2 is the exercise book. It provides you with 12 step-by-step guided exercises. Again, it's the NI style kind of approach. Part 1 starts with learning how to create a new worker. Then you go through how to create trees, how to create APIs, how to add a message pump to your application, how to load workers dynamically and plug them in dynamically. Part 2 then goes through all the OOP features, how to create a base class, and you finish by learning how to create a hardware abstraction layer. So beginning of day 1, create a new worker, end of day 2, creating hardware abstraction layers. And this was designed to be taken after core 3. This was my northern light. Every time I made a decision about what features I should add to the framework, I was always asking myself, can I use this framework after I take core 3? This is what I was missing. After core 3, this was what I was missing. I wanted something that would take the knowledge that I learned in core 1, core 2, core 3, and allow me to apply it in a scalable, modular, and flexible way. OOP is not a prerequisite. It helps, but the framework, the tools do the heavy lifting for you. It's very simple. You only need to remember that a class is a library with superpowers. And I know from experience, from teaching this to other developers that have no object-oriented experience, that yes, this course and this, sorry, not the course, but the framework is very approachable and easy to use. It's great when you see a developer start to use the framework and they're at the core 3 level or they're a CLD, and then this light bulb goes off in their head and they're like, I know this is familiar. And that always puts a smile on my face because that's exactly what I intended the framework to do. Then we have the new Workers Community online platform, which was released about a year ago. This is the homepage now for the framework. So here you can access the framework's training course. We also have a new certified support partner program, which there's 2 companies in Switzerland that have been using the framework for the last 5-6 years now for all their internal and external projects. They also provide mentoring to other companies and teams that want to start using the framework. What else do we have here? Oh yeah, so under the Getting Started tab, you have the link that takes you to the VIPM page for the framework. We have the official user guide, which is also linked to by every tool. So every scripting tool has a little help button at the bottom of the tool that will send you to the correct page of the user guide. We have some tutorial videos that show you how to create a new worker, create a public request, etc. Very simple things. They're only 60 seconds long each, so you can watch all of them in 6 minutes. And then we have the GitHub repositories also. There's 3 now. The debug server is actually a Workers 5 application, which is kind of cool because you're actually debugging your Workers 5 applications with a Workers 5 application. And it's an open source project. It's also a great example of how to use the framework. So you can also pull that from one of the GitHub repos. We also have, so it's the place to come, this website, for all the latest announcements. There's going to be an emailing list, which is starting soon, so you can basically sign up to the website as well. There's a wish list here. If you have any bugs, add it here. There's a question and answer section as well. And I'm also trying to write a quality article once a month about good software, a solid article once a month, solid design principles as well, on how to use the framework, good software architecture practices. So these will be also available every month on the website. So Workers for LabVIEW is easy to use. If you can develop with the National Queue Message Handler template or DQMH, or if you're at the core 3 level, CLD level, then you probably already know how to use Workers for LabVIEW, you just don't realize it yet. So please download it, try it. I'm available on LinkedIn. You can also post any questions on the website's question and answer page. Give me your feedback. It's a hobby project of mine, so I'm continually developing it. More and more people are starting to use it, which is actually great. And that's all I have today. Yes, Eli.
If I were to open one of the methods in the public API, is it just putting something in a local queue for that QMH?
Exactly.
Okay, and so then the interface, whatever data structure it expects, is that a variant then? That's
the type if that's converted to a variant.
It is converted to a variant.
Yeah.
Cool.
By the way, good job.
Thank you.
Yeah, great, thank you. So my first question is that, so why did you name it as Workers?
Sorry?
Why did you name this framework as Workers?
Oh. Because it kind of models the structure of people in a company, where you'll have like a CEO, he'll be at the top, and then you'll have his top line managers, and then you'll have like a hierarchy of people. So this started off actually being called the manager worker framework. So we have workers and managers, but then because I actually didn't have just workers, the first version had a worker, which you couldn't plug anything into it. It was like the bottom of the tree. And the ones that you could plug things into were called managers. But then as the framework evolved, everything basically became a worker, became a lot more flexible. The tools became more flexible. The architecture became more flexible. So now we just have workers. So it's like in a company, everyone is a worker. They all do a unique job. They communicate with each other. There's a kind of hierarchy. So that's where the name came from.
Okay, thank you. The second question is that, so how is the request and a response transferred in your Workers?
Good question. I didn't talk about that. So every worker, every caller creates a priority message queue for every worker. It's the same message queue that is used by the actor framework. So you can set the priorities of your messages. I forgot to talk about that. Let's go back quickly. Where's the tree? Here we go. Okay. Yeah. So workers, developers can set the priority of their messages to either low priority, normal priority, or high. There is a fourth priority, critical, which is reserved by use of the framework for the initialization and shutdown sequences of an application. So if you want to shut down your application, you will send the shutdown command to the head worker, and the shutdown command will be propagated with a critical priority message through the application to all the other workers. So that doesn't matter if you have thousands of messages in a backlog for a worker, you will have deterministic behavior. The application will shut down. The message will be received ahead of all the other messages. So for priorities, it's the same as the actor framework. It's the same queue in the background. Yeah.
Okay. And also a question is that, is there any shortcut to invoke the window that I just show the workers window? Is there any shortcuts to invoke that window?
Shortcuts for?
Like a quick job, yeah.
Oh yes, there's quick job shortcuts also, yes.
Okay.
Yeah. And there's might be another toolkit coming out soon by someone else who actually is adding some additional shortcuts to the project.
Okay, the last one, sorry. Yeah, so I guess no, but I want to confirm, is Workers available for Mac in LabVIEW or?
I mean, I love Mac's hardware. I only use Windows though, so I haven't tried it on Mac.
Okay.
No.
Okay, thank you.
Yeah. And it works from 2017 LabVIEW onwards, the framework. It's free. So the scripting tools are all locked. All the code that you compile into your own application, so the framework's API, that's all open. And the debug server is open as well. So everything that you might be compiling into production code is completely open and accessible. There's nothing to hide from developers.
But the scripting tools are not open source?
Correct. That's my IP.
Yeah, I was more interested about the debug server part of it. So is it like a single debug server, like per project you have a debug server, or is it like a?
So you have one debug server for, it's a Windows application. It's just one.
Okay, so you have to set up upfront like all the workers are talking to this debug server?
No, it's automatic. So you just run the application,
Okay.
debug server, and when you launch your worker,
Okay.
there's a little background client which is invisible, which is a TCP client, which will connect to the debug server. The developers don't see that. This happens in the background. And when you shut down your application, the debug client in the background is killed as well. So there is a background, it hooks into the debug server application, but you don't see this. This happens automatically. When you launch an application, it'll immediately come up in the application message log, in the debug server's application manager.
Okay. So like it's a standard port they are listening to, and
Sorry?
it's a standard port the server is listening to.
Yes, and it's TCP, which is very lightweight. You can compile it into your applications, run it on your compact Rio. It's flexible, lightweight. The work's been done for you, so you don't have to worry about it.
You don't have to make it debuggable. It's always debuggable.
Correct.
Quick follow-up question on that. Can you turn off messages that you don't want, you've got in loops that you don't want?
Yes, you can. Yep.
I think Chris has got this.
Okay, I just saw.
Right.
Go, Chris.
Chris, yes, please. Yeah. Toss a coin.
So I'm noticing that you have the clone ID there. So
Yep.
you may be susceptible to a problem that we had. Actor framework keeps the reference of the first actor live. Mm-hmm. And we thought, oh, we're so smart. We're not going to do that. We're just going to use the clones. And there's a thing called the root loop in LabVIEW. Mm-hmm. Are you familiar with that? Mm-hmm. So if somebody were to come and use your worker that has a GUI and mm-hmm. opens a menu, and then they walk away because they got a phone call, mm-hmm. your whole application is going to hang. Mm-hmm. So in order to remove that, it's just a LabVIEW thing. It's mm-hmm. It's nothing you're doing. It's a LabVIEW thing.
Yeah.
So when you're using BI Server to launch a new clone, anyone else that is trying to do their own framework or their own thing, go open the launch root actor and you'll see the description there, or go open our start module and you'll see the description there on how you need to use the open BI server, what flag you need, and then make sure you keep that reference available. And that will make sure that you're not susceptible to the root loop issue.
Okay.
So the first step will be for you to go try this.
Yeah.
And what I do is I put a DQMH module, just counting. Right? Yeah. And what you want is if I open a menu in another window, that thing keeps counting. If it stops counting, you're susceptible to the root loop issue. Okay,
I'll have to try that. Is this written in the actor framework code?
It's in the launch actor, and it will be also it's also on the start module for the DQMH module. And I can send you the YouTube video where I show.
Yeah, that'll be great if I can test it out.
Yeah. If I have to but that's just for everyone else that think that they got it like I did, and then be like, we can turn it off. We put a thing to turn it off in case.
Yeah.
You don't want it.
Okay. Thank you. Chris.
Hi. Yeah, thanks, Peter. That's super impressive. I know what I'm going to do when I get home this afternoon. I got a question.
It's funny. A lot of the terminology that you use, like superpowers.
Yeah.
It was like when you were saying it, I was like, has he seen my presentation already? Like there's a lot of overlap. So
yeah,
anyway,
that's right.
Yeah.
But it seems that you've taken like all the things that we're dreaming of in all the frameworks that are circulating around, and you've completed them all already. And you have a free product that uses them all. So, that's great.
Thank you.
I got a question about launching.
Yeah.
So the call tree, the call chain, whatever you call it, the hierarchy.
Yeah, the worker call chain.
You kind of manage that dynamically, I think, or at least you've got scripting tools for managing that tree. Is the launching then centralized, or is each parent within the tree calling its child?
Every parent in the tree calls its child.
Right. So
there's two ways to connect the parent worker to the tree. You can either have it statically linked to its caller, or you can dynamically load it at runtime. For example, the hardware abstraction layers are dynamically loaded. You plug the public API of the base class statically into the caller, and then at runtime, you dynamically load whichever worker you want to run on the API abstraction.
Yeah.
So there's a combination of statically linked code and dynamically loaded code.
Right, but then the structure of the tree is static for the life of the application.
Well, no,
I wondered if you
can
could
load
implement it so you could kind of dynamically load things,
yes,
and then just reconfigure the routing of messages to effectively reshape the tree.
Well, you can reshape the tree in many ways. I mean, some of my recent projects, I've used API abstractions for every single worker. So you have no idea what the tree is going to look like because you can plug in things at runtime. So it depends on what you're plugging in, defines the shape of the tree. And you can also load multiple instances of the same worker multiple times. So if you have like a main worker with subpanels, and you have like 12 subpanels, and then you can load 12 workers dynamically, then the tree will start growing every time you dynamically load a new worker into the tree.
Yeah.
Yeah.
Got it. That's great.
So sorry, Chris. Are you saying the tree is live, linked into the monitoring tool? So when you're running an application, you can see the tree grow based on how many workers are active in memory?
Yes. I mean, here you can see also that, the type of workers. You can see here, wait a minute. Yeah, so SL, statically linked, DL, dynamically loaded. So you can see how they're plugged into the tree. And you can see that this one here is actually 2 instances of the same worker because this is TCP read client 1. This is an alias. Every worker needs an alias. You can't have 2 workers of the same alias running at the same time. And you can see that there's 2 clones of the same worker. So this worker was plugged in, was loaded dynamically twice into what's caller. And we have 2 instances of its main VI running.
Any other questions?
Actually, I've got one, Pete. So say I've got a DQMH application and I'm liking the hardware abstraction layers. That's something I could easily incorporate in underneath a DQMH module, Pete?
I can give you a contact of a guy from Zulke in Switzerland who's actually kind of merged the 2. Well, he's kind of like made a kind of a DQMH module that allows you to couple frameworks so that you can go from the messaging type of workers into the DQMH messaging type and vice versa. So it is possible, but it's something that you'd have to do manually. But I've seen it done.
What is that called? Dequirkers or something?
Yeah. That's a good name. That's a good name. That'll catch on. But I do know someone that you could contact who's been playing around with that. Yeah.
Is that Fab? Is that the company that have the project provider?
I believe so.
For DQMH?
Yeah, that's okay. Yeah.
In your monitoring tool, you had a pack libraries as a standalone section in there. I was wondering if you had any headaches with pack libraries.
So I don't use them personally. One of the support partners uses them extensively. And all the problems that the active framework faces with packed libraries, Workers has as well. So there is a way to do it, but he solved all these problems by just working out how to do it in active framework and then copied it and it worked in Workers. So, okay. Yeah.
So I'm thinking about Instrument Studio and creating some Instrument Studio plugins with Workers.
Yeah.
So in this case, I'm going to have 4 CEOs. 4 guys at the top. I got my power supply, my function generator, and a scope. And they're all going to be a worker and ultimately get plugged into Instrument Studio. So any issues with having 3 CEOs at the top?
I mean, there'd be 3 separate applications.
3 separate applications that are worker-based, running at the same time.
Yep.
No problem.
No.
Great.
No.
I knew that was the answer.
No. How do you communicate between them?
Your queues wouldn't work.
How do you communicate?
Your queues wouldn't work between the application instances, but the TCP would work.
Totally separate companies.
Oh yeah.
Different
No problem.
Yeah,
no problem.
To be clear, they're not going to be talking to each other because they're all going to ultimately three separate companies, and each company has its one CEO, and they never talk to each other.
Does that make the developers the shareholders? Also, how would you rate the efficiency of middle management? I have lots of questions.
Yeah, but no problem with that. No.
I actually love the analogy to organizational structure because there actually are a lot of like, do you have a really flat hierarchy? Do you have a lot of middle management? Like, what is the efficiency and who can talk to who? And it's a interesting way to conceptualize it.
I mean, you can also communicate from between sibling workers at the same level if their manager passes their cues to each other. So again, this is organizational messaging decision. You can,
Doesn't allow them to talk directly.
Also,
everything has to go through them.
Not a problem.
Interesting on the middle management side of things, because we had a customer, we've used a plugin architecture. It's not based on workers, but it's got a lot of overlap.
Those are interns.
Well, we had a customer with the situation where we've got 3, 4, we actually had 7 odd applications for them. They said, oh, we actually want to run 4 of these applications on one PC, but we don't want the operators to have to switch between them. So we made a middle management program or a middle management class to basically take the functionality of the applications, stick them in, and then dynamically load it in one application that can then act as many different applications as they want in the end. So yeah, you can add in that middle management and have lots of companies. I think it's getting there.
The organization.
Any other questions?
Yeah, you're right. They're interns. They're contractors.
All right.
The question was, do you get any spare time from Tim?
Do I have any spare time? Oh, I wish I had more. I mean, it's this project. So the first 2 years, I was doing this like two and a half. I had a 50% job because I really wanted to get like the foundation of this up and running, and then I've been using it ever since. I mean, I'm an end user, so it makes my working life much more efficient. And also, I work at a university with people that don't know what they want. Okay, so they kind of want everything. You have to be very flexible. You start off with a small project, and then the crazy scientist will come to you and say, okay, we want to add this sensor system, and we want to add this, and we want to change that. So as a developer, you need to have a flexible system, because they want prototypes like spread out like that, and you can create completely reusable modules as well. Plug them in, change things. Hardware abstraction layers, easy to debug, which is good. We have a lot of compact RIO systems as well with FPGAs, so it's great to be able to develop in the same way on a Windows host PC as you can on a real-time system, and debug it in the same way as well, because that was always annoying. Where you go from developing on a Windows PC, and then when you start doing things on NI real-time systems, it's kind of a different feel, and how do you get data out, and how do you debug? So this is designed to kind of like just cut through all that and make it easy for the developers. I'm an end user, so I want it to be as simple as possible.
All right, I think we'll leave it there. Thank you, Peter.
Thank you.